Visible right now. Yeah. Okay. Good evening, guys. Good evening, everyone. Welcome to this introductory presentation about Coursevita. Coursevita is an innovative learning platform designed to provide flexible, high-quality education to learners worldwide. So our mission is to make learning accessible and manageable even for the busiest individual. With a wide range of courses in various fields, there is something here for everyone. Everyone who wanted to start learning. So let's dive in and see what makes Coursevita special. Oh, okay. Hello. Hi, guys. Can you hear me? Could you please
Yes,
confirm it by raising your hands? Okay. Yeah. Sure. Perfect. We'll get started now. So yeah, good evening, guys. Welcome to this introductory presentation about Coursevita. So Coursevita is an innovative learning platform designed to provide flexible, high-quality education to learners worldwide. Our mission is to make learning accessible and manageable, even for the busiest individuals out there, starting from students to working professionals. With a wide range of courses in various fields, there is something here for everyone. So let's dive in and see what's make Coursevita special. But before that, let us dive into inviting our speaker for the day. So we have the privilege of welcoming Dr. Sanatan Sukija as our esteemed speaker today. So Dr. Sukija earned his PhD from the prestigious IIT Ropar, where he made significant contributions to his field of study. Currently, he is an assistant professor at Mahindra University, where he continues to inspire and educate the next generation of scholars and professionals. Dr. Sukija is here with us today to share his insights on higher education in data science. His extensive knowledge and experience in this field make him an ideal speaker for the topic. So at Mahindra University, Dr. Sukija is known for his engaging teaching style and his ability to make complex concepts accessible to students. So we are honored to have him here today to talk about the opportunities in data science and future directions of how data science career would look like. So please join me in welcoming Dr. Sanatan Sukija. And coming back, so why you should choose Coursevita at the first place? So, firstly, our courses are designed to fit into your busy schedule with flexible learning options. The bite-sized lessons make it easy to learn on the go, and also the downloadable materials ensure you can study offline whenever you have time. Additionally, our industry recognized certificates can help boost your career prospects. Coming to our testimonials, we have success stories from a lot of people who have attended their past workshop and are also a part of Intern Vita program that Course Vita has been conducting for the past 3 weeks. So Nikita Verma says that Course Vita has a good selection of courses on various topics. She says that she mentioned about the platform being very user friendly and easy to navigate. And the content which was found on the website is also a very quality content, and a lot of people could make benefit out of it. And Anvita Chaudhary has quoted that Coursevita is a very decent platform, and especially if someone is looking for like free introductory classes and workshops, then this is your place. And 8 out of our 10 learners are pleased with our courses. So if you wanted any other info into our reviews, please make sure to visit our Google reviews page where you'll have complete access to the reviews from a lot of people. So how do you join? Like if you're ready to take our next step in joining our learning, joining Coursevita is very easy. Simply you can sign up on our website, and also you can write to us at reach us@coursevita.com. All the updates on our social media platforms will be given at least a week before the workshop. And also every update regarding the workshop and also the start of a program will be promoted through our social media platforms. We also have special offers, so be sure to check out those as well. If you have any questions or need assistance, our contact information is provided, which is research@coursevita.com. So thank you for your time, and I hope to see you soon on Coursevita. Without further ado, let us deep dive into Dr. Sukija's presentation today. He's here to teach you and give you some glimpse on how future in data science would look like. So, Dr. Sukija, on to you right now.
Hey, thank you. Okay, I hope I'm visible.
Right.
Yes, sir. You are visible. You are visible and audible.
Yeah. Okay, guys, I plan to deliver it in a interactive style. So feel free to ask any number of questions in between. Can someone confirm if these guys have unmute privileges? Or
I think they can unmute themselves. Yeah.
or okay.
They can unmute.
Or okay. I hope my screen is visible to me.
Yes.
Thank you. So we'll have it in a programming style. Just give me like 10 to 20 seconds, okay, to set it up. And instead of say typing it in the chat window, I would prefer if you guys directly interact with me. So just unmute yourself and feel free to ask any number of questions. All right, guys. So see, I'm going to start with a quick introduction to how data science, AI, and ML are changing the higher education, okay, how they impact the higher education. So to give you a brief motivation, why is the need for data science, AI, and ML, like why are they necessary? So what we'll do is we'll take a small example to go through everything, okay? So let's talk about what is data science first, okay? See, data science is a data-driven domain. What I mean by data-driven domain is that for certain tasks, it is difficult to come up with a formula, or maybe say to come up with an algorithm, okay, to essentially perform it. So just to give you a slight idea, let's say if somebody asks me, okay, what are the stock prices going to be, say, in the next 2 days for a particular company? So there is no algorithm as such that you can use, which can essentially tell you, okay, you fit. So there is a formula which exists. You put in the value and it will tell you whether the stock price will be, say, X or stock price will be, say, Y. Okay, so there is no formula as such. So you think about, say, weather forecasting. Okay, so the objective here is to figure out what could be the temperature, humidity values, maybe the wind speed, whether it will rain or not. Okay, so for all those things, there is no algorithm known to mankind. So what we can do instead is, and you can extrapolate it to anything that you do on a day-to-day basis. So maybe let me quote on this. Do you think that, let's say, if there is an algorithm which can help you detect congestion in traffic or congestion on roads? So let me tell you, there is no such algorithm. However, what most of the companies, what they do, or what Google is doing, they collect live data and they try to use that data to predict where the congestion is going to be and how it can be resolved by navigating the users through different routes. Okay, so you can extrapolate it. So think about, say, image recognition. Okay, let's say I give you an image, and if I ask you, who is the person in this given image? Now, you as a human can do it very reliably. However, if I ask you whether there is an algorithm for it, now some of you may say yes, but no, there is no algorithm as such which exists where you feed in the image and it tells you 100% accurately who the person is. But what can be done is you can collect a lot of images about the individuals you want to identify, okay, and then you can essentially train certain models through that data that you collected, and that can be extrapolated to figuring out the identity of that individual in the given image. I hope that makes sense. Okay, so I'll put it this way. See, for all those tasks where a human does exceptionally well, okay, but there is, okay, so this is the crux here. Okay, so for all those tasks where a human is doing exceptionally well, or let's say relatively well, okay, there might be certain tasks where a human cannot actually do well. So think about stock prices. Okay, all right. However, it is difficult to write a program though. Okay, so it is difficult to encode the expertise of a human in the form of a computer program, okay, or in the form of an algorithm. Okay, so at all those places you do data science, or you can say that you can model your tasks in such a way by collecting a lot of data and then try to learn from it. Okay, I hope that makes sense. All right, so that's like the whole objective, like why people do data science. Essentially, they want to figure out, you can say, information or insights by collecting a lot of data. Some people call it knowledge also. I mean, there are a lot of synonyms that you can put here. So your objective is to figure out, say, the patterns in the data, and then use those patterns, okay, to do the desired task. So let me take a small example and illustrate how you can do this, and then we'll talk about the challenges and what is ongoing in higher education with all these things. Okay, so I'm going to take a small example. Let's take a small data set. Okay, so let me take like, yeah, so I'm going to take like something which all of you do. Okay, one second. So I'm going to take like a small data set, and then I'll quiz you on something. So this is, let's say, the data set that we have. Okay, so let's take this data set and try to do certain things with it. Okay, and I'll try to explain how your ML, AI, and data science fits into it. Okay, so let's say this is one data set which is given to us. Now you can imagine that each row is the set of products which a particular customer is buying. So I'm just writing C1, C2 as some customer IDs. So you can imagine that there are 5 customers in this data set. Okay, so there are 5 customers in this data set, and each customer is buying a certain set of items, right? Now think about this. Okay, it's a relatively small data set, so all of you can look at it and derive some insights from it, derive some knowledge from it. So one of my questions to you is, if you are say a grocery selling company, let's say you are Big Basket or Flipkart Grocery, or you can think of say maybe say Zepto or any other e-commerce platform, and you are selling these products, and I give you this data set. Okay, and this data set comes from the transactions of your customers. Okay, my question to you is, so maybe one of you can unmute yourself and tell me, what are the things that you would like to extract? So what are the things that you would like to do, or that you can tell your manager, so that manager can do something and it can help your company to grow? Any guesses? So you can write it in the chat, or you can unmute yourself and speak up. Either is fine. So anyone?
No, sir.
No idea. Okay. So see, one of the questions that you can ask, okay, let me give you a hint here, is which is the best-selling product? Okay. So I hope that makes sense. So going along these lines, can you figure out a certain other thing? Think about it. Think about it. Like, there are several people. You can type it in the chat window, or you can unmute and probably have a small interaction with me. Anyone? No ideas? Okay. So see, one simple thing that you can do, I'm asking in plain English. I'm not asking you exactly how to do this. That I'll do. Whatever you tell me, I'll show you how it can be done. So, see, one small idea is, that you can actually figure out, okay, which is say the best selling product or best selling products. Okay, let's call say the top K products. Okay, so we want the top K products from our data set. Okay, another would be, do you think that some of the products share some kind of associations? So typically, say 2 or 3 products are sold alongside each other. Does that make sense? So there are associations between the products, or you can say relationships. So some products are complementary, right? So suppose that somebody is buying bread, okay, they are likely to buy eggs. Okay, so things like that. Okay, typically onion and kidney beans, they form like a good association. Okay, so I want to figure out these associations, and if I can figure out these associations, I can generate recommendations. So if you have ever been to Amazon or any other e-commerce website, right? When you look at a product, it shows you certain recommendations. Now, there are so many different ways to generate recommendations. And one of these ideas is you see the associations between the products. So I'm just going to show you, okay, how these things can be done. And these are fairly easy to do. And that is what data science is all about. So I'm talking in very generic sense. So the idea is, given some data set, okay, we are talking about a very relatively small size data set today, but we'll talk about big data and other things in just a bit. So our objective is to derive some insights which can help your company to grow in some way. So it could be revenue, it could be say optimized delivery. So if you talk about say such data sets, okay. So let's start with analyzing some of these like best-selling products. Okay, so what I'm going to do is I'm going to create like a structured version of this data set. So if you see here carefully, right, all of these individual transactions done by these customers, they share different number of products. Okay, so I'm going to put it like in a tabular format, though it may look already like a tabular format to you, but let me do some reformulation of this data set. I'm going to transform it in a certain setting where things become fairly easy. Okay, so let me just apply. Forget about what I'm writing. Okay, you don't need to understand this at this point in time, but let me just do this quickly. Okay, so I'm going to essentially figure out all the unique products. And if a product is present in a transaction, I'm going to say it's a 1. If it is not present, it's a 0. Okay, so just see the results, and hopefully you'll be able to understand what I just did. Okay, so just a second. So, and you can see that I don't really have to write a lot of, you can say, I mean, a lot of steps. Okay, 1 second. Okay, I'm almost done. And I'll talk about what I'm using, in which language I'm coding, and so on. Okay, 1 second. Okay, so this is how the data set looks like. So essentially what I did, I figured out all the unique products, and you can see these unique products are these. Okay, all right. And if you look at the first transaction, okay, I'll just copy this first transaction for you. Okay. Okay. Now, do you see that in the first row, wherever these items are present, there you see a 1, and otherwise you see a 0. Does that make sense? So if you look at milk, right, corresponding to milk, there is a 1. Corresponding to onion, there is a 1. Okay. And same thing has been done for the other rows as well. Okay. The reason I did this is that there can be, I mean, a lot of mathematical simplicity if I use this type of data. Okay. So let me talk about what kinds of data could be provided to you so that you get an understanding of what data science is truly all about. Okay. See, the term data science has this data, right? I told you it's a data-driven domain. So can you briefly tell me, or can you at least list out what are the possible forms of data that you see in day-to-day world? Anybody? Which is the most prevalent form of data that I'm showing you right now? What is it that I'm writing? I'm writing a lot of text, right? What is it that you do on Instagram or say Facebook? Which type of data do you share on Instagram a lot? Any guesses? Okay, so I don't think like many of you would like to interact, but anyways, so you think about images and videos, right? Okay, same thing. If you think about it, like data can be in the form of audio, or it can be like a hybrid of everything. Okay, now this is what we call it as raw data. So typically, when we start to do data science, right? Whatever data that you want to have, okay, whatever data that you want to have, it comes from a specific domain, and typically it will be from these domains. Okay, so these are the most popular domains or most popular types of data. Now, there are problems when you start dealing with, say, raw data. So if you look at text contains strings. Okay, if you look at text contains strings, right? Now, what I did, I converted it into these numbers. If you see that right now, I converted them into numbers. Essentially, working with numbers is much easier because I can do additions, subtractions, deletions, and so on. Okay, but working with, say, textual data, okay, is fairly difficult. We will talk about it like as we progress, but the idea here is, so we deal with different formats of data. Okay, so I'll call it different data representations. Okay, and there are two popular data representations. There are actually many, but I'm going to talk about two popular data representations today. One of them is called as structured, which is your typical tabular data set that I'm showing you here. Okay, so this is the typical tabular data set. Okay, and the other one I would say is, say, unstructured, which is this one. Okay. Now, how to differentiate between unstructured and structured is, see, if you look at a structured data set, okay, every row is actually the same size. Okay, every row is actually the same size. Essentially, I am saying that there are the same number of columns, okay, in each row. Okay, all right. But if you look at this unstructured data set, do you see that it's like if you look at row 3 and maybe say row 2 is much bigger than, say, row 3. Okay, and other rows also share some kind of, I mean, they don't share like a similar structure across these different transactions. Okay, so this is just to give you an idea. And obviously, you can have like a hybrid, which is semi-structured. So there might be certain parts of data which are structured and some parts which are unstructured. Now, there are different other formats beyond. So I can give you examples. So there might be graphical data where you have nodes and edges. Okay, there might be say spatial data where data is given to you in form of, say, maps. Okay, it depends on like what type of data that you're working with. So you have to format this data first and then start working with it. Okay, now before even you get any data, one thing to note is this. See, you have to store it somewhere. Okay, now, so one of the concepts comes in, which is data storage. Like, so typically most of these companies, okay, they use the cloud service. Okay, they store their data in cloud servers. Okay, now what I mean by cloud services is you think of as if there is another device which is not physically accessible to you, but you can use that device by logging into that device through some like authentication credentials. Okay, for now you can imagine it like this. I think most of you are using say OneDrive or Google Drive. So Google Drive is a type of a cloud service where you can store your data, right? And you can access it through your Google credentials. Same thing with Microsoft OneDrive, and you can take examples from Dropbox and many other services. Okay, so this is just to give you an idea. Now, all these concepts, where the data is stored, how the data is stored, does the data needs to be encrypted if it is sensitive? So there are ethical considerations. Okay, so all these concepts come under data engineering. Okay, so this is just to give you an idea. Data science entails concepts of data engineering, where typically when you work on a project, right, there are other people who assist you with getting the data to your device. and those are data engineers. Now, these like data engineering concepts, they entail a lot of other stuff. Nowadays, I mean, we have transitioned into this big data analytics, where the volume of the data is humongous. So if I talk about, say, the data being generated at Amazon, so like I have worked in Amazon, so I can tell you very briefly like how much data is generated, maybe say in 1 week. So it is closer to around 13 petabytes. Okay, and that is just about the transactions. Okay, so close to 1 week of data is around 13 petabytes, and you can understand this number is pretty big. Okay, so you need special kinds of tools, frameworks to do all these things. See, currently I'm using maybe say some 10 or 20 kilobytes of data. Okay, and I'm trying to process it. Okay, what I'm talking in the context of Amazon is in petabytes. Okay, which is around 10 to the power 11 times more. Okay, I hope you get the context. So we need special tools or frameworks. I'll talk about these frameworks, what you can do. Okay. Now, currently what I'm doing is I'm running a platform which is called as, so this platform that you see, this platform is called as a Collab Notebook. Okay. Now, what this Collab Notebook offers you, so essentially you can write your code in Python. Okay. So Python, as you know, is a programming language. So you can write your code in Python here. So what I'm writing is Python programming instructions. Okay. I'm using some Python, you can call it libraries, some specific libraries to do some desired tasks. And as you can see, for me to just convert this to this, I just wrote these 4 lines. Okay, and it was like quite an easy thing to do. And if you do a little bit of practice, you'll become, I mean, an expert in no time. Okay, so the idea is there are a lot of popular languages in which you can do this stuff. Python and R are at the forefront of it. So I would say that you can either go with Python or either go with R, and they both have all the prerequisite set of tools to get started with data science, AI, and ML, and even data engineering. Okay. All right. So this was just to give you an idea. Okay. Now let's try to understand. Okay, some other fundamental elements. Okay. So I'm going to save this, maybe say in a variable called as df. Okay. Now, what we want is the top selling products. Now I want you to see this. So what I'm going to do is I'm going to sum up each column. Okay. And if I sum up each column, you can see that kidney beans is going to sum to 5, which means that it was bought by all the 5 customers. Okay, so look at this. So I'm going to sum up all the columns. Okay, and if I ask you, just look at this data and tell me which is the best selling product, you would say that, okay, it is kidney beans because it is sold the most number of times. So maybe what I can do is I can sort this data. Okay, and I can put that in the descending order. Okay, and you can see it that kidney beans is the top, then you have eggs, then you have milk. And let's say you want the top 5 products. So you can get these top 5 products like this. And you can see this is very easy to do with some like very easy Python constructs. Okay. Now, what we are doing right now is we are using Python programming language, and we are using some specific toolkits. So I used 2 toolkits, or you can say 2 libraries so far. One of these libraries is called as pandas. Now, this pandas library is used to work with tabular datasets. Okay, if you see carefully, I use this library pandas here. Okay, the command import is there to import a library. I mean, let's not get into the code right now, but I just want to talk about like there are already existing toolkits that you can use, and you can do everything and like almost everything with just minimum lines of code. So these programming languages, Python and R, they support an enormous number of libraries, and they can ease all your day-to-day data science, AI, and ML tasks. Okay, so this is just to show you. Okay, now please note this. If I summarize it, see, this pandas library is actually good for up to maybe like 5 to 8 GB worth of data sets. So if you want to use this library, I would put it this way that I mean, if you're running this library even on a machine which has, say, 16 gigabytes of RAM, pandas will give you good efficiency if your data sets are up to, say, 5 to 8 gigabytes. Okay. If you start going beyond, it'll become fairly slow. Okay. Because it is because the way these functions are implemented in pandas. So I'm not going into the nitty-gritties, but when I say this, just take it from me that there are other libraries where if you import them as the data set size grows, they do the same thing as pandas, just you need to change the library name. Okay, so let's say if the data size grows bigger, I would recommend that you try using a library called as Polar. You can go with Modin, you can go with Wakes, okay, and you can try CUDA data frames. Okay, so these are some libraries that you can try if the data set size is, say, hundreds of gigabytes or even bigger. Okay. Okay, and I would put them in this increasing order. Okay, they are in the increasing order. Okay, so they can even work with, say, petabytes worth of data, as long as you have the memory. Okay, so currently, let me call it terabytes. So as long as you have the memory to do it, if you are working on, say, a company's cluster, you can use these libraries. And the best part is you don't have to write, you don't have to change much code. All you need to do is use the library name. So just like I have imported pandas, right? You will write import Polar, okay? And rest of the things remain the same. Most of these functions in these libraries, they have the same name. So you don't need to change much of your code, okay? So this was just to give you an idea, okay? Now, I just showed you, right, like how to figure out these top K. And this can be really useful, like in the essence that if you have a website or if you have an app, probably you can show these products to all your consumers on the front page, and they are also likely to buy it. Okay. So this, you can say these are like the top selling products that you can recommend to your user. Okay. Now, certain products are bought together with each other. So I want to show you this. Can you figure out certain, say, pairs or triplets? So can you give me a combination of products which are sold together, say, most of the times? Anyone? So if you look at the data, can you tell me which pair of products are sold together most of the times? Any guesses? Okay, maybe I'll show you this. So if you look at eggs and kidney beans, so eggs and kidney beans are sold 4 out of 5 times together. Okay, so you can say that if somebody is buying eggs or somebody has eggs in their cart, you recommend them kidney beans and vice versa. Okay, so you can actually figure out associations between these different products. So again, let me show you how easy it is. So all you have to do is, okay, you have to use any like one library. I'm going to use this library called as machine learning extensions. It's called as MLXtend for short. So just to give you an idea, I'm using this library, machine learning extensions. I'm going to show you which products first are sold, I mean, a lot of times. So let me just finish this quickly. Okay, so I need one algorithm to figure out, you can say, the pairs, the triplets, which are sold frequently with each other. Okay. Okay, so I need my data set, which is this DF. And I have to give some threshold. So I'm saying that if a product is bought 60% of the times or more, then or even if a pair of products is bought 60% of the times or more, I'm going to keep it in my recommendations. Okay. So, and I'm just keeping these product names. Okay. So this is just to show you, these are the, you can say, frequently bought products. Okay. Let's call it frequently bought. So I've just used one algorithm which can essentially figure out the frequently bought products. So if you carefully see, these products are bought frequently more than 60% of the times. So these are individual products that we figured out. Okay. If you sort it, these are actually the top 5 products that I showed you. Okay. Now, I want you to see these are some pairs which are bought more than 60% of the times together. And there is a triplet also, which is bought, say, 60% of the times together. Okay. Now, I'm going to show you how you can generate recommendations. So I want you to consider maybe say this pair, milk and kidney beans. Okay. So let me just go to the data. And I have a question for all of you. So please think about this. So I have these eggs and kidney beans. Okay. All right. So I want you to think about it. So there are two products which are sold very, very frequently. You can see they are bought 80% of the times together. Okay. So you can essentially make a rule like this. If somebody has bought eggs, you can suggest kidney beans. And the other way to look at it is if somebody has bought kidney beans, you can suggest eggs. Okay. I want you to tell me which rule, whether it is say rule 1, let's call it say rule 1, and the other rule is rule 2. Okay. Out of these two rules, which rule is more stronger? So I want you to interpret it like this. If somebody has bought eggs, this means that in how many transactions when somebody bought eggs, kidney beans was also bought. So if you look at this carefully, there are 4 transactions where people bought eggs. Out of these 4 transactions, did everyone buy kidney beans? The answer is yes. So you can interpret it like this. Okay. People buying, okay, both together divided by the number of times eggs was bought. Now, if you look at this number is going to come out as 4 divided by 4. So how many times people bought both of them together, which was, so if you look at the data set, 0, 1, 2, and 4. So 4 times they were bought together. And the number of times X was bought was actually 4 times. Okay. So this gives you the idea that this rule has you can say a like a value which you can quantify as 1. Okay. So higher this value, you can say more stronger is the rule. Now I want you to figure out this rule. So this rule will slightly change where you will say that, okay, people who bought both items together divide by number of times this kidney beans was bought. Okay. So if you carefully see this, 4 times people bought both of them together, and out of 5 times the kidney beans was bought. Okay. So this rule is 0.8. So if you carefully see, the first rule, rule number 1, is much stronger than rule 2. Okay. So what I'm suggesting is, it's not always that if 2 items, if they are bought frequently with each other, you should suggest one if the other person. So in this case, I would say that eggs implies kidney beans is much more stronger than kidney beans implies eggs. Okay. So make use of this rule and probably discard this rule if you have to. Okay. So I'm going to show you how you can get to all these rules. Okay. Just a second. So again, you don't have to do much. There are already algorithms for it. So I'm just showing you how you can build like simple recommendation systems. So let's try to use one of the rule finding algorithms. So I'm using another algorithm which is called as association rules. There are so many different algorithms that you can try, which are which are alternatives of this. I'm trying something which is fairly faster. Okay. So you have to pass these frequently bought items to this. Okay, and this is, so I'm giving this threshold of around 0.85. So everything which has a score of greater than 85, okay, should be reported. Okay, and the metric that I'm using is called as confidence. How confident I am in a particular rule. This is actually called as confidence. Okay, the way I'm computing this is called as confidence. Okay, so let's call these as rules. Now I'm going to show you just 2 things from these rules. Okay. And let me print the confidence also so that you can see. Okay. 1 second, there is a subtle issue. I misspelled association rules. Here also. 1 second. Association. Okay, so I want you to see this carefully. See, do you see that eggs implies kidney beans is coming, but kidney beans implies eggs is not there? If you see this, this is one of the rules that we figured out that was more stronger, okay? And the other rule did not come. So these are all the other rules that you can use. And how you can interpret this is like this. So if somebody is buying eggs, or if somebody is looking at eggs, you can suggest kidney beans to them on that web page, okay? Or other way to put it is, if somebody has already added eggs in their cart, you recommend that person kidney beans. So they are likely to buy kidney beans. Okay, so treat these antecedents as those things which have already happened or are happening. Consequents are those things which the person is likely to buy. Okay. All right. I hope that makes sense. So this is like one easy way to generate recommendations. Okay. So see, data science, all in all, it's an interdisciplinary field. Okay, which uses concepts from, so let me just put it this way. So I've just spoken about one simple task, which was recommendations. I'll talk about more. Okay, so it's an interdisciplinary field. Excuse me if I write anything like incorrectly, if there is a spelling mistake. Okay, so now, what does this field entail? What is it that you have to study if you want to make it big in data science, AI, and ML? See, first of all, you need to be fairly good with computer science concepts. Okay, so that is something. Okay, you have to be good with basic mathematics, I would say. Okay, so in basic mathematics, I'm going to list, say, some of these domains where you must be good at if you want to excel in this domain. So one of them is probability. I will put statistics in this category. Okay. You can probably do a little bit of optimization theory. Okay, so optimization theory is also something that you can need. A little bit of calculus to understand the basics of the algorithms. So integral calculus and differential calculus. And I think these are like the basic mathematics concepts. Maybe a little bit of linear algebra if you want to talk about how good an algorithm is in terms of matrix computations. So let's call it linear/matrix algebra. So these are the things that I recommend from the basic mathematics perspective. Now, see, this domain also needs you to be good with a little bit of data engineering. So I would put, you need to be good with some data mining concepts, where you have to essentially extract insights. So what I started with was a little bit of data mining. I tried extracting some of these, you can say, important products, which I feel like can be put as recommendations. Okay. Another thing which I would recommend is probably learning about some cloud engineering concepts. So you must be knowing that there are a lot of companies which offer their like cloud platforms. The most popular ones are Amazon. So Amazon Web Services you can use. You can use Microsoft Azure. You can use Google Cloud, IBM's Cloud. I mean, there are a lot of companies which offer it. Okay, Salesforce Cloud is there. I mean, more than 100 companies are there in this sector. Okay, so that is something. Now, so this was about essentially the very basics. Okay, so I would say around 10 to 15 years back, the domain was using very fundamental principles or simply descriptive statistics. So just to give you an idea, so previously most of the recommendations were done by just generating some numbers. So if you think about this, here I generated just numbers, right? And more the sales, you can say the product can be recommended to the customers. So previously people only did these recommendations. Now, if you think about it, I can generate maybe say more numbers. So just to give you an idea, so I have this data frame, and let me show you some descriptive statistics about your data. Okay, let me just put it like this. So if you see, essentially the count here tells you how many times the product was essentially present in the data. So it is possible that sometimes you don't have an entry in the data set. There might be missing values. So you will see count is probably less than 5 in some cases. This is the mean value, which tells you on an average how many times the customer has bought this product. So if you look at Apple, only one customer out of 5 has actually bought it. So if you look at this data, right, Apple is only bought just by one person. So 1 divided by 5. Okay. So that is the average value. So you can actually just look at descriptive statistics, some basic statistics, and figure out whether a particular product is supposed to be recommended or not. And this is in the context of recommendation systems. Depending on the task, you use appropriate statistics to decide whether a product should be suggested or not. Okay, this is standard deviation. If you come from maths background, you know that standard deviation measures the spread of data. This is the minimum value. So essentially, if you look at the column of Apple, the minimum value is 0, maximum is 1. And these are some percentiles. So 25%, 50 percentile score, 75 percentile score. Okay. So since the column only has zeros and ones, so that's why you only see 0 and 1 here. Okay. All right. So these are some descriptive statistics for each product, and you can use some of these statistics to recommend. So maybe you can use the mean. So if the average number of sales are higher, then you can recommend. Okay, I hope that makes sense. Okay. And obviously, standard deviation should be low, which means that most of the customers are buying it. Okay. So if you look at kidney beans, like this is like the perfect product which everyone is buying, because the mean is 1, which means that it is bought at least once by every customer, and standard deviation is 0 implies that because every customer buys it, so there is no deviation as such. Okay, I hope that makes sense. Okay. So so previously data science was done using descriptive statistics, but as the research grew, okay, as this domain expanded, then came machine learning. Okay. So in machine learning, what we do is we try to do mathematical modeling of data, okay, to understand or to derive certain patterns, you can say, to derive certain patterns that can be used for making predictions. Okay, these patterns can be used for making predictions. Now, let's take maybe say another example to to visualize how machine learning helps. Even this algorithm which I showed you, association rules, it's kind of a predictive algorithm. It tells you that if somebody is buying eggs, okay, the person is likely to buy kidney beans also. Okay, so this is a kind of a machine learning algorithm, but previously people used to just look at these descriptive statistics, and later on they incorporated machine learning to it. So let's take a small example to understand what machine learning can do. So the idea is, let's say this. Okay, maybe I want to figure out if somebody has cancer or not. Okay, so let me just look at certain tasks. Okay, and let's try to do one of these tasks to understand. Okay, so I'm going to take say one of these tasks. Okay, all right. So let me take this data set, maybe simpler one. Okay, let's say I'm trying to predict the impact of diabetes. Okay, so we want to predict the impact of diabetes on the health of an individual. Okay, so we want to use this data set that is available to us. Now, my question is this to you. If you want to see like how much a person is impacted by diabetes, obviously there is no algorithm, right? So what characteristics of an individual would you like to note or would you like to record so that maybe say it can be shown to a doctor and then the doctor can make a recommendation? Anyone? What can you actually record about say the characteristics of an individual which can help us predict whether like what is the impact of diabetes on the health of an individual? Any guesses? And that is what is learning from data, identifying the patterns from data. So what data would you like to record about individuals? Any guesses? And you have to record the data about a lot of individuals. And when you record this data, then you can do some mathematical modeling of it. And then you can predict how much is the impact of diabetes on the health of a new individual also. Okay. So anyone? Blood pressure is one. Any other? Do you think age matters? Age, gender, probably BMI, blood pressure, as you mentioned, glucose levels, right? Right. Okay. So let me show you what this data set is all about. So we have this data set available with us. So a hospital recorded this data set and made it available for everybody to understand how some conditions or how some of these characteristics affect the diabetic, you can say, affect the impact of diabetes on the health of an individual. Okay. So let me just load this data and show you. Okay. 1 second. Just forget the code. Okay. Your code is not relevant to you right now. Okay. So let me show you what are these characteristics. Okay. Let me put everything nicely in a table so that you can understand this. Okay, I want you to see this carefully. Okay, so essentially what they are recording is the age of the person, the sex of the person. Don't focus on these values. These values have been kind of standardized in the range of, I think, -4 to 4, something like that. Okay, so don't focus on the range. Sex is essentially male or female. You will see only 2 types of values here. Okay, BMI is you can say the body mass index, weight divided by height squared. Okay, the blood pressure. These are some blood tests. Okay, and these blood tests are indicative of. So let me show you what are these blood tests. So if you are interested in knowing, okay, so let me show you this description of this data. Okay, so the description is this. It says that it has 442 samples, 442 individuals, and there are around 10 columns. So 10 essential features. So age, sex, BMI, average blood pressure, and these are some blood tests. So you can see this is cholesterol levels. This is low density lipoproteins, high density lipoproteins. So S1 to S6 are some blood tests. S6 is glucose, as somebody was suggesting. Okay. These are triglycerides levels and so on. So one hospital has recorded this data set for us. Now, for these 442 individuals, okay, see, for these 442 individuals, we are given this data. And if you look at this, say, first individual, let me show you this first individual. Let's call it data. Okay, let me just save it. Let me show you the data of the first individual or the first 5 individuals. Okay, so this is the data of the first 5 individuals. I want to show you the output. Okay, what is it that we are interested in predicting? Okay, so this output that you see for the first 5 individuals is this. Okay, so I want you to interpret this number. So higher the number, more the impact of diabetes on the health of the individual. Okay, so if you look at this first person, which has these characteristics, these values, the impact on the health of the individual is 151. If you look at the second person, which has these values, the impact is 75. So it is saying that the second person is impacted lesser in comparison to the first person. Now, who gives us these values? These values are given by doctors. Now, I can use these values. Okay, I can use these values to predict what is the, you can say, the health status of a person. Okay, so what I'm going to do is, I'm going to show you how you can do this. So essentially, in machine learning, okay, you can solve a variety of tasks. Okay, currently what we are doing is a supervised learning task where we have data and the output given by the doctors in this case. So in supervised learning, for every input, we have a corresponding output given to us. And you can essentially do 2 things in it. One is, so if you look at this particular task, we want to predict these values, these output values, the health parameter values. Okay, higher the value indicates that more is the impact of diabetes on the health of the individual. Okay, so if you think about this, these values are actually continuous. Okay, essentially we want to predict this value on a real number line. So you can predict a continuous variable. Okay, that is one of the tasks under this setting. And you can also predict, if you think about it, you can simply predict if a person is diabetic or not. or you can call it as a discrete variable. Okay, so you can either do continuous variable predictions or you can do discrete variable predictions. Obviously, there are two possibilities, right? A variable can be continuous or it can be discrete. So what we are currently doing is prediction for continuous variables. We are predicting the amount of the impact of diabetes on the health of the individual through a number. Okay, so it's a continuous variable. If it was predicting whether a person is diabetic or not, it would have been discrete, yes or no. Okay, so I have one question to you. Let's say you are doing image classification. Given an image, you want to identify which individual it is. So are you predicting a continuous variable or are you predicting a discrete variable? Can you tell me this? If you do image classification, which type of prediction are you doing? Are you doing a continuous variable prediction or are you doing a discrete variable prediction? Anyone? Think about assigning. See, so it's like saying, maybe say you have 10 friends and I give you a picture. From that picture, you will map it to one of the individuals, right? Either it would be 1 or 2 or 3 or 4 or 5 or 6. It cannot be 1.1. It cannot be 1.2, right? So don't you think it is discrete in some sense? Okay. It is actually discrete. Okay. It is a discrete problem where you can think in terms of like this. For the first person, the answer is yes or no. For the second person, the answer is yes or no. I mean, for the 10 individuals in the data set, for each of them, don't you think you are saying yes or no? Does that make sense? So it's a discrete variable. Okay. Now, keeping this in mind, let me ask you another question. If you are going to predict whether it will rain or not today, what do you think? It's predicting a continuous variable or a discrete variable? Whether it will rain or not. Is it discrete or continuous? Now, I hope this makes sense because it's a discrete variable, right? Now, if I ask you predict the amount of rain in millimeters, then it becomes a continuous variable. Okay. So I hope there is now some clarity, at least in the sense that you can now identify whether you are predicting a continuous variable or a discrete variable. So if you are predicting a continuous variable, these type of tasks are called as regression tasks. Okay. And if you're predicting a discrete variable, these type of tasks are called as classification tasks. Okay. Your machine learning algorithms, okay, they are available in abundance. Okay. I would say there are more than 20-30 algorithms that you can do, okay, for doing regression. And similarly, there are again 30-40 algorithms that are available for you to do classification. Okay. Currently, we are doing regression. So I'm going to show you one simple idea. Okay. I'm going to show you one simple idea. Okay. So maybe I can show you with one simple example. Let's try to use this BMI to predict the impact of diabetes. I'm going to show you just maybe say with a limited data set. Okay. So let's try to do this. And I'll show you one important aspect which I haven't described yet. Okay. So what I'm going to do is I'm going to use essentially the BMI, okay, to predict the output. Okay. So, and let me take just 5 individuals. Okay. So just to show you, I'm going to take the first 5 individuals and taking this, what is the column number? It's column number 2. The index is 2. Okay. All right. And from this, I have to take the first 5 individuals. Okay, one second. Let me give some labels. I'm going to show you a plot. Okay, I wanted to think about this, what I'm doing. Okay, just give me a moment. So x-axis would be your BMI, and y-axis is the impact of diabetes. Oops, sorry. Okay, I want you to see this. Okay, and maybe I'll just zoom out a little. Okay, so let's say this is what the data looks like. So every point that you see, so for this person, the BMI is actually, let me show you the data also. Okay, so let me show you the data. Okay, for these first 5 individuals. So the first value is around this Okay, so it's not plotted in order. So if you look at this last person, this is around 0.061. So this value is around 0.061, and the corresponding output is, okay, and the corresponding y-axis is this 151. Okay, so this person whose BMI is this value, the output is 151. Okay, if you see this value, this is around 0.061, and the output is around 151. Okay, I hope the data at least makes sense to you. Now, I have a question. Okay, let me just give one small point to you, and I want you to predict. So I'm giving you a new. Okay, let me just do it like this. So I'm giving you a new person, and this person has the BMI of. So let me just take a small value. Let me say the value is around 0.039. Okay, so I'm going to take. So I have to need a vertical line. Okay, so this is just to illustrate. Okay, so I just took this line. Okay, so imagine that there is a person whose BMI is around 0.039. I want you to tell me, just by looking at the data, okay, which of these individuals is the closest to it? This line is closest to which individual? Can I say this is the individual which is the closest to? Because this person has the BMI of around 0.039. And this person whose BMI is around 0.0444, this is the next closest individual to it. So I can say that this person, because this person has the impact of diabetes as 206. So, sorry, this person has the impact of diabetes as 141. Don't you think I can also predict somewhere in the range of around 141 as the predicted value for this person? Does that make sense? See, all I'm saying is if you look at this person whose BMI is around 0.039, it is closest to this individual. And this individual shares a value of around, what was the value? It was around 141 or something. Yeah, 141. So because this individual shares this 141, I can actually predict for this 0.039 somewhere very, very close to this 141. I hope that makes sense. So what I just did was I did like simple searching. I found out the closest person which shares the same BMI. I know its impact of diabetes from the data. And I simply say that, okay, this, I mean, whatever the value of this closest person is, I predict it as my, you can say, predicted output. Okay. So I just showed you like one simple algorithm. Now, please note this, all these algorithms are individually implemented in a library called as scikit-learn. Okay, this is also called as scikit-learn. Most of the algorithms that you will study under this machine learning domain, okay, they are all implemented in sklearn. I would say the most popular ones. If you want to look at some least popular ones, there is another library called as scikit-learn extra. Okay, there is another library called as scikit-learn extra, which has some other algorithms. If you want to work with, say, some non-traditional ones. So this one has traditional algorithms. This one has a little over. Okay, so you can say that this library has some of those niche algorithms which are used in specific use cases. But this one has all the ones which are predominantly used. Okay, now you can use these. So let me show you how to use these. Okay, all right. So let me just show you. Okay, so I'm going to show you the exact idea. Okay, so I'm going to use these. So let's use this. Use the same idea that I showed you. I'm going to implement an algorithm called as using k neighbors. So I will specify only use the closest neighbor to make a prediction. Okay, so let me implement this. Okay, so I'm implementing this algorithm which uses, say, one neighbor. So I implement it on my data. So my data is having just 5 examples. Okay, and my output is this, the 5 outputs. It needs a reshaping. So one second, I'll. Okay, so the model is ready, and now you can predict for any new example. So what this model will do, okay, this model will essentially figure out which is the closest person. So if you look at, so I'll give you one value, okay, and you tell me what is the answer for it. So I'm going to figure out for a value say 0.04. Okay, and so let me show you the data also so that you can. So this is your data. Okay, so this is the data. I want you to tell me which person is the closest to this value 0.04. Which of these values is the closest to 0.04? Okay. And you can see that this 0.044 is the closest, right? Let's look at its impact of diabetes, and the impact of diabetes is around 141. So this algorithm will also say that because you are closest to this 0.0444, the answer should come out as 141. So let me just do this. Okay, I'm just reshaping this. This is required, I mean, due to some, you can say, columnar conversions. Okay, sorry. I need to use one more library for it, which needs to. Okay, one second. Just a second. Okay. Let me convert this to an array first and then reshape it. Okay, so if you see that the output is 141. Okay, now let's try another value. So if I go to a value, maybe say 0.058. Now, can you tell me which value is the closest out of all these? So out of all these, which value is the closest? Anyone? Which value is the closest? To 0.058. This is the closest, right? 0.061. No, this would be the closest, right? To 0.058, if you carefully see. So if this is the closest, okay, if this is the closest, the output should be 151. Okay, so let me just show you. It predicts the output as 151. Okay, so depending on whatever value that you're passing, it figures out which is the closest person to it, which shares the same value, okay, and predicts the given output as the predicted output for that person. Okay, so that's how you can use like data to predict for new individuals. Okay, so these type of algorithms, they require a lot of data for you to do this. Essentially, you need to have a humongous amount of data to do such things. Now, see, I just showed you one algorithm right now. There are literally 20, 30 of these algorithms. Now, you will ask me, sir, now how do I know which algorithm is working the best? So there are some inherent assumptions about these algorithms. So you should first do some kind of exploratory data analysis first and see what is the type of data that is present, what is the distribution of the data, and other things to choose the algorithm carefully. Now, if you are not into, say, mathematics, or say if you do not want to go through all that trouble, then let me show you there are libraries which can directly compare 20, 30 algorithms in one shot. Okay, so I'm going to show you a library called as PyCaret. Okay, these are called as low-code learning platforms. Okay, these are called as low-code libraries, or you can call it as low-code frameworks. So you just have to write very few lines of code, and you can directly compare 30, 40 algorithms in one shot. So since we are doing regression, I am importing everything. Okay. I'll just import on the entire data. Okay, just give me a second. So this was my data, right? I think I called it data or df. I have to check this. Okay, just a second. I think I called it data. Data. Okay. So I'm going to use the entire data now instead of, so this is my data. Okay, I'm going to use this entire data now. Okay, but I have to first give the output here. And the output is in the column Y. Okay. So let me create a setup where I'm comparing many algorithms. So this needs the data as, so my data is called as data. My target column, which I'm trying to predict, is called as the output. Okay, I just added this output column just to show you. Okay, in my original data, I added this output column, which tells me what is the impact of diabetes on the health of an individual. So the first person has 151, second person has 75, and so on. This is what I'm trying to predict. Okay. So I'm going to run a lot of algorithms on it. Okay, let's see. All right. So I'm going to run a lot of algorithms on it. Okay. Just a second. So it is trying to set up some of these files. Okay. So this has set up all these experiments. Okay. So I mean, not diving into too much details of what it is doing. I'll just show you the results. So see, it will appear like magic to you because it will compare all these algorithms and will show you directly the results in different form of quantities. So I'll talk about those quantities in just a bit. Okay, so let me show you. Okay, so it has started comparing all these algorithms. Okay, it will take like 5 minutes to finish this. Okay, 2 to 5 minutes to finish this. So as you see, as the algorithm is being done, okay, so it is run and the results are reported. These are called as some evaluation metrics. Okay, so you can interpret it in this way that this value, it's actually called as mean absolute error. Lower the better, smaller the value, better the model. Okay, MSE is mean squared error. Lower the value, better the model. Root mean squared error, this is actually the root of the square root of MSE. R2 score is higher the better. This is also root mean squared logarithm error, lower the better. This is higher the better, mean absolute percentage error. And this is time taken. So we would want to sometimes use the time taken to train an algorithm because we have to eventually deploy it in some service, right, to our website and so on. So you can make, you can say, a decision based on time taken also. Okay. So these are, so some of the algorithms are still running. Okay, give it some time. Okay. And you will see that once this is done, it will actually arrange all these algorithms to the best of these evaluation metrics. Okay. So just give it like 2 more minutes. I think one or two particular algorithms are taking more time. Is my voice breaking or is it all right? Yes, people. Is my voice breaking or is it all right? Yeah. All right. Actually, this algorithm, the one which is currently running, it's taking a lot of time. And I was getting this message that my CPU quality might deteriorate because most of the RAM is being utilized. Just give it like maybe 1 more minute. Okay. But anyways, so meanwhile this runs, let me tell you that there are a lot of other low-code learning libraries. You can try h2o.ai. This is a remarkable platform where you can do the similar things. Okay. There is a small Python package called as Lazy Predict. It is not that good, but I mean, I wouldn't advise to use it, but some people, when they are having a time crunch, they go by this library. Okay. You have a lot of other libraries like Alteryx. It's mostly used for data engineering people. Okay. You can try maybe Data Robot. So these are some low-code learning frameworks which are quite good. So if you work in the industry, you will be using one of these frameworks. So typically, you don't use individual models unless you have like the domain expertise to decide, okay, which one to exactly pick. Okay. Now, another aspect, okay, is which I showed you here. Like one of the simplest aspects is you would want to see some visualization of data so that you can convey to your managers, okay, the information which is present in your data, the hidden insights in your data. Okay, so you can say visualization or plotting is another important key concept in data science. Okay, even in ML, you would want to show the results in the form of some plot or some graph or chart, you can say. Okay, so that's another aspect of this data science AI and ML, which is quite crucial. One thing I'll do is I'll just stop this. Okay, just stop this. Otherwise, it will take a lot of time. Okay, just stop this. Okay, so some algorithm was taking a lot of time, but this is just to show you. Okay, I just stopped it, so you're seeing these messages. Okay, I just interrupted it. Okay, so this was just to show you. Okay, you can use some of these frameworks. Now, there are other types of machine learning tasks. You can do grouping of data, essentially customer segmentation. Okay, you can figure out which customers are similar to each other, and that you can do for say recommendations. If you think about say searching on Google, so Google search uses an algorithm called as page ranking, where when you type a search query, it returns these documents or these web links to you in a sorted manner. The page which is most relevant to you, it's returned at the top, and then the relevance keeps on decreasing with each subsequent document. Okay, So you can use the ideas of grouping to do these things. In machine learning lingo, they are called as clustering algorithms. Okay, they come under the context of unsupervised learning. Now, please note this: you can do a variety of things with data. Okay, and I mean, I've just given you the tip of the iceberg. There are more types of tasks in machine learning. One of them is called as reinforcement learning, which is becoming quite popular these days. If you have seen autonomous cars, or if you have seen robotics, where essentially some robot is trying to do a particular type of task, let me tell you, most of these are trained using reinforcement learning algorithms. Most of them. Okay, if it's a robotics related task, it's typically trained using reinforcement learning. The idea is very simple. Essentially, if you do a certain action, if it's a action that leads to a you can say a positive response, if it helps you reach your destination, then you give it a reward. And if it so essentially the model tries to learn with a set of actions and states. If you move from one state to another through an action, and the action leads closer to the destination, you are awarded with a you can say a positive score. But if you move away, you are awarded with a negative score. So your objective is to maximize the amount of reward that you can collect, or you can say minimize the amount of penalty that you want to get at the end. So these concepts are coming under reinforcement learning, and they are mostly used in robotics. Okay, most of these autonomous cars are actually using the reinforcement learning algorithms under the hood. Now, please note this: all of these things, data science, AI, and ML, they are actually quite interrelated, or you can say they are actually subsets of each other. So if somebody asks me, okay, what is the relationship between them? So data science has an overlap, okay, with a strong overlap with machine learning. Okay, so if you try to draw the Venn diagram, so let me just switch on to my another device, and we'll just finish up with this. Okay, one second. Okay, I hope the screen is visible. Okay, so when we talk about say data science, if this is say all the things that I can do under the data science hood, and if say this is machine learning, okay, then they share, or I will put it this way, okay, there are some things in ML, I mean, quite a lot of things in ML that you leverage for data science. Okay. Similarly, there is this buzzword called as deep learning. Now, to put it very precisely and concisely, deep learning is nothing but it's a domain which uses neural networks. Neural network is a type of a machine learning algorithm which can be used for a variety of tasks. All these tasks that we discussed, right? Regression, classification, reinforcement learning. For all those tasks, you can use neural networks. Okay. Grouping also. Okay. Whatever comes to your mind, for all those tasks, you can use neural networks. Now, deep learning is a special type of a machine learning algorithm. So deep learning will come somewhere here. And deep learning is now, or let me put it this way. Okay. Most of the things in deep learning, you can actually now use in data science also. So most of the applications that you see, they are now deep learning based. Google search engine, deep learning based. Okay. Translation on Google. So if you're using Google Translate, it's deep learning based. Okay. Detecting congestion. Okay. The underlying architectures are deep learning based. Image classification. So, or let's say you're passing through a toll and they detect your license plate number automatically. That's also through a deep neural network. So most of the times, or most of the applications that you use, they are all deep learning based nowadays. Okay. Now, but they have their own constraints. They require a lot of compute resources to train them. But now that we have advanced quite a lot, any questions as such? Just a second. It's I think from Nikanksha. Let me just meet her. Okay. Okay. So the idea is this: that anything that you see in deep learning will be, I mean, a subset of machine learning. You can do a variety of tasks with this. And where does AI come in? See, AI is the bigger set of ML. Okay, I'll put it like this. I hope you can see this. So this is where AI lies. Okay, so AI also has an overlap. Let me tell you what AI is and how is AI using all these things like data science, DL, and ML. So see, if there is a system which can take decisions on its own, okay, then you call it as an intelligent system. Okay, for example, if you think about an autonomous car has several different modules which are running in parallel, and they help the car decide where to go. So think about it. If you have seen an autonomous car ever, okay, there are lidar sensors on top of it. Okay, there are also cameras on top of it. So do you think that it might be doing certain tasks, multiple tasks together, whether there is a obstacle or not in front of me, whether there is a breaker or not in front of me, how much speed I should be moving with, okay, whether to take a left turn or right turn, whether to go straight or not, at what angle I should turn. So don't you think all these tasks are running in tandem? And what is helping it? So machine learning algorithms are helping it decide what to do. Now, please note that machine learning algorithms just give it a prediction. Now, if you give the power to the system to take an action based on the value, then you can call it as an AI system. Okay. Now, if you have been using models like ChatGPT, okay, I'm not sure whether you have had a chance. Okay. Do you call these models like ChatGPT or Gemini to be able to can they understand, say, human text very, very accurately? Do you think they are a self-capable system? I mean, they can interact with you and probably suggest you whatever you're asking. Would you call them having some kind of intelligence? Yes or no? Does that make sense? So those are an AI system. They have a full-fledged mechanism from start to end. So if you give them some input, they give you the desired output. Obviously, they are not taking an action right now. Okay, they are not taking an action right now. So you can say that they are a service which is being deployed, which uses some kind of a learning algorithm to generate the output based on the prompt that you pass. Okay, so you give it some input and you ask it to do certain things. That is called as a prompt on a certain input. Okay, and it gives you the output based on the prompt and the input that you provide. Okay. So it's not truly an AI system because it is not taking any decision, but it is still helping you with your tasks. Okay, so it is still intelligent. So there are aspects to it which machine learning algorithms don't have. So if you give machine learning algorithms the power to plan, okay, the power to take actions, then they become an AI system. Okay, same thing with DL. So this is how I would summarize the overlap between all these different entities. Now, one key thing is, where are all these things used? See, you refer to any course. It could be a bachelor's course on, say, business administration. It could be an engineering course, or it could be, say, a computer applications course. So any course which is related to, like even in courses which are non-computer science, they are teaching ML. Okay. So let's say if I talk about mechanical branch, okay, they are using machine learning and AI in construction related fields, where to drill, okay, or how much to drill, okay, or whether there is a defect in a particular monument, okay, whether and monument needs servicing or not. So people have started using machine learning in a lot of construction related aspects. Okay. So just to give you an idea, machine learning is now so pervasive in every aspect of life that you are doing. It is currently being used. You tell me any website, or rather I challenge you, tell me one website that you think doesn't use machine learning. I'm pretty sure you'll not be able to come up with one name. I can guarantee you whatever website that you're using nowadays, whichever website that you're using, it uses some kind of machine learning. Machine learning, deep learning, any website name that you think it doesn't use it, I give you a challenge. Okay. And I'll tell you where exactly ML is used. You tell me the name of a website, I'll tell you where exactly machine learning is used. See, Google uses page ranking. If you're using Facebook, have you seen it suggest you recommendations? It used to do segmentation of faces. Okay, previously it has removed that. It used to classify or automate the labels, the names of the people in the images previously. It has stopped doing that due to some ethical reasons. Okay, the posts that you are seeing, they are being suggested through some machine learning algorithms. Same goes with Twitter. If you visit any e-commerce website, there you see recommendations. Okay, I mean, you go to YouTube, you see recommendations. Okay, ads that you're seeing, they're all done through ML. No website that you use nowadays is without ML. Okay, no website. Even Coursevita people, they probably use some kind of ML, or they use some kind of human knowledge, okay, to target individuals so that they can also I mean, enroll in their courses. Okay, so it's a two-way thing, right? Using ML for the good. So please understand this. You are not living in a world anymore where I mean, you're not living in an era which was, say, 20 years before. So everywhere or anywhere you go, you are going to be surrounded by all these ML AI systems. And most of these learnings, most of these courses are now equipped with such subjects. And you have to learn them at some point in time if you want to succeed in the real world. And most of these jobs, so if I talk about the highest paying jobs, they are actually that of a applied AI ML applied scientist. Let me just mention it. Okay, an AI ML engineer. Okay, maybe say a prompt engineer if you talk about these large language models like ChatGPT. Okay, a data scientist, a data analyst, or a business analyst, like anything that is related to data, I would say all things that are data driven. Okay, all jobs that are data driven are actually the highest paying jobs. Okay, all right, let me just put it. See, I can tell you this from my experience because I've worked with some companies as a applied scientist, as a graduate researcher. So like I started my journey with HCL, moved to Siemens. Then I had short stints at Intel and Amazon. And then I moved to this organization called as Mahindra University, which is a subsidiary of TechM. Here, I train undergraduate, postgraduate, and even Tech Mahindra professionals in the art of ML and DL. Okay, so trust me when I say this. These things are going to be one of the most relevant. I mean, these data-driven domains are going to be one of the most relevant domains in the next 20, 25 years or so. Okay, and you should think of upskilling yourself in this domain as soon as you can, especially if you're doing some kind of an undergraduate course. And obviously, if you want to transition from one domain to the other, like these are worth considering. Okay, because obviously everybody needs money, right? Okay. So any job, okay, be it a data analyst or say business analyst, okay, I mean, or finance analyst. I mean, you can just keep on writing. All these data-driven jobs, okay, are actually the highest paying jobs. Okay, these are the highest paying jobs, are the highest paying ones, typically. Now, I'm not saying people still need good software developers. Okay, that's another area, but at least over the last 2-3 years, or not 2-3 years, maybe like last 5-6 years, the trend has now continuous. I mean, it has been changing. Okay, and these jobs get more traction. So I'll stop here. If you have any questions, you can ask. Okay, feel free to put it in the chat window, or you can unmute yourself and discuss. So any questions as such from anyone?
Yeah, hi, Samantha.
Hi, could you please increase your mic volume?
Once.
Yeah.
Yeah, hi, Samantha.
Hey.
Thank you so much. The session was went very well. So yeah, thank you so much. And I have to inform one announcement in the session. Thank you, team, for joining the session today. I hope you have enjoyed a lot. And how to announce one thing. So I have shared the feedback link in the chat group. Okay, so kindly take a moment and provide your feedback. Okay, so it will count as your attendance, today's attendance, and also you will get a certificate. Within 2 days, you will receive the certificate for today's session. Okay, so kindly provide your feedback. So then only it will count as attendance, and also you will get the certificate. Okay. And also maybe tomorrow you will receive the recordings of today's session, and also as soon as possible you will get the materials also in the WhatsApp group. So you can follow our links like YouTube and Instagram and WhatsApp pages. Okay, how mentioned in the chat box. Thank you so much. Yeah, thank you, Sanatan. Thanks so
All
much.
right. So can I leave now? I don't see any questions in the chat.
No, nothing. I have just posted. Okay, so everything was clear.
All right. So bye everyone. I hope you
Yeah.
had some good takeaways. Take care. Have a good night. Bye.
Yeah, thank you so much. Yeah, thank you, team. So kindly forward your feedback. Okay, so then only you will get that today's attendance and you will receive the certificate.